Hello, my beautiful computer science students. Welcome to another lesson in Unit 7. Today we're going to go over Lesson 4, which is developing algorithms using an array list. Right? So common algorithms, we run into the same ones with that we had with arrays. There's just some common tasks we're asked to usually perform on an array list, and these algorithms just tend to pop up frequently. Depending on the task, you might be able to use an enhanced for loop, but usually a regular for loop is the way to go, specifically because we might be modifying our array list. If you're ever modifying your array list, you have to use a regular for loop. If you're ever just accessing or displaying an array list, you can use an enhanced for loop for that task as well. So just know that, and as we go through, we got 3 algorithms I think we're going to go through today, and as we go through them, I'm going to use a regular for loop, but just know you might be able to use an enhanced for loop. All the algorithms that we did with arrays, you'll want to know how to do them on an array list. Luckily, there's not too much difference. A lot of the difference ends up being just syntax. Again, just because of the auto boxing feature, just a few different points with the syntax are usually the only thing that's different between the 2 algorithms with an array or an array list. So these are the 3 we're going to go over in this lesson. Using this array list, we are going to be writing code to accomplish a task, and that task is going to be kind of a common algorithm that we'll use. So here I have an array list of values. Here they are, and I want to do something with them. This first thing I want to do is write a code segment that prints off the index and the value of whatever the smallest element is. Okay? So we can look through that list and see the smallest element is -8, but we want a general code segment that allows us to do that. So let's talk about what steps we need in this algorithm before we actually write the code. So we need a variable to keep track of the location of the smallest element, so the index. And keep in mind, if we know the location, so if we know the index, you also know the value, because you can get the value using the index, right? So we'll loop through the list and compare each element to the min element that I have, okay, the min index. And if that min element at that index that I'm keeping track of is larger than the current element I am at in my list, the current element is the new minimum. Okay? So I'm comparing elements, but I'm keeping track of the index, the location of that smallest element. Okay? And then I print off the information that I want it to print off. So those are my 5 steps. So first, I need a variable to keep track of my minimum index. And usually we just assume that the lowest element comes at index 0. So we're just going to set that equal to 0. I'm not going to set it equal to -1 because I know there is going to be a smallest element. Okay. So I'm going to loop through and compare it to the element that I am recording as my min. So I'm going to start off thinking that index 0 is going to be my min. Now, technically, I start at I equals 0 here. If you already assume index 0 is your min, you can start at I equals 1. But here, as you can see, if you start at I equals 0, it's not that big of a deal. You just kind of get an extra traversal of the loop that has no consequence on that min index. But how am I going to compare? So I'm going to do values.get min index, okay, because right now min index is 0, but I'm going to get what that element is, because I got to compare elements. I don't want to compare indexes. And then I'm going to get the element at whatever current index I'm at. If my min index ends up being larger than where I'm currently at, if this element at min index is larger than where I'm currently at, that means that this is going to be my new minimum. Okay. Now all I have to keep track of is the index, the location of my minimum. So min index just gets changed to I. Okay. And then I print off the contents. So what the smallest element is, I use the get method to get what element is at min index, and then the index location is just min index. Okay, that's one of the common algorithms you might see. Okay, is traversing to find something, basically, is what you're looking for. Now we're going to write a code segment that prints off the average of the positive elements in the list. Okay. So you have a list of integer values, and we just want the average of the positive. So if it's negative, we don't want it. What are the steps? Step 1, you got to keep track of the sum. Okay, so a variable to keep track of the sum. Loop through every element in your array list. Check if that element is positive, and if it is positive, add it to the sum. At the very end, after the loop, we calculate the mean by taking that sum that we have and dividing it by the size of the array list. Okay. Ooh, excuse me. And I noticed something. So the size of the array list, I did not take this into account. So we only want the element added if it's positive. So that means when we find the mean of all the positive elements, it's not just the size of the array list, right? So in my example, I'm going to take off this. I'm going to have 6 values that were added to the sum. So I want to take eventually the sum divided by 6 because that was the number of positive elements. If I use the dot size, then I'm actually going to be dividing it by 7, which is not what I want. Okay, so it looks like we're going to edit this in real time here because I did not read that closely enough when I made this slide. So I'm going to change that. So I want a value to keep track of the sum. What I'm also going to want is to keep track of how many positive numbers were added to the sum. Right? So I'm going to need another variable. I'm going to just make it an int. I'm going to call it n. And that's going to stand for the number of elements I'm going to add to my list. Okay. And then you can see I'm going to actually use an example of an enhanced for loop because I'm just accessing elements of my array list. So I'm checking to see if it's positive, and if it is, I'm adding the element to a value. I'm not going to change the content, so an enhanced for each loop, or an enhanced for loop for each loop will work. So for every integer in values. So this is my current element that I am on. Okay. So I check to see if it's positive, and if it is, I'm going to add that element to sum. Okay. Now here's where I'm going to put back in. Okay, right? That n keeps track of the number of positives. Inside this if statement, I also want a value that increases n by 1 because that's going to be the number of elements that were positive. Okay, so just a small change to what I have on here, but an important one if I want it to actually do it correctly. And then at the end here, so kind of annoying I have to add this every time, but that's what I get for making a mistake, I guess. Or just an oversight. Caught myself. So now when I print off the mean, I take that sum, but I don't divide it by values.size. Okay? I don't do that, again, for reasons we've been discussing. Instead, I'm going to divide it by n. Okay? N. In my example here, the number of positive elements is just size minus 1, but that might not be the case. Okay, it might be size minus 4, size minus 10, right? This works for any array list. So it would just be better to keep track of n, the number of positive elements, and take sum divided by n there. Okay. Yeah. All right, the last algorithm. Let's see if I did this one right. Write a code segment that removes an element from the list if it is even. Okay, so we'll go through and remove all elements if they're even. Now, since I'm removing elements, I'm going to be changing the array list, so I already know I'm going to be using a regular for loop. Okay. So I want to loop through every element in the array list, and since I'm removing elements, I am going to start at the back, okay? Start at the end of my array list, because logically I don't want to skip any if I'm moving forward. Okay? If the element is even, so I'm going to have an if statement, I want to remove whatever that current index is, and that's my algorithm, 2 steps. Okay, 2 steps. So I loop through the array list backwards. Values.size minus 1 is my last index, and decrease I until I get to 0. I check to see if that current element is even, and there's my check. If values.getI mod 2 is equal to 0. If it's even, I want to remove it. Okay. If it's not, then I'm not doing anything. Yeah, okay. So it accomplished my task. So those are 3 examples of some common algorithms. Back in Unit 6, we did a whole bunch of common algorithms with arrays, and you'll probably be asked at various times to use those algorithms on an array list. Okay. Okay, the last thing I want to talk about in this lesson is array list as parameters and returning array lists. So what happens with an array list as we work with methods, essentially. So when passing an array list to a method, it's important to remember that you are passing a reference. Okay, when you're working with array lists and methods, it actually works identically to an array. You're passing references, so that changes made to the array list in a method affect the original array list. Okay, so here's an example of what that means. So I just put a lot of code on the screen, so I'm going to give you a second to kind of see it. I have my import statement here, public class example. Here's my main method, and I also have a method down here called mystery. Okay, you'll notice that mystery, this is how we write an array list as a parameter. Okay, so this method accepts an array list of integer values and is going to call it list. Okay, so if you're passing an array list as a parameter, that's going to be your syntax. Okay, here this is creating a new array list of integer values called numbers. And then here is actually where I'm going to add values to numbers. Okay, so what gets added? Well, k is 0, k less than or equal to 20, k equals k plus 3, add k plus 2. So k here does not represent an index. K is just going to represent a number, and we're going to add the result of that operation to my array list. So the first time through, k is 0. And I add k plus 2, so I'm going to have a 2. Then k increases to 3. 3 is less than or equal to 20, so I add 3 plus 2. Then k gets 3 added to it. 6 is less than or equal to 20. I add k plus 2. And I keep going until I am above 20. So by the end, numbers are going to contain those values. Okay. You can trace through if you want to confirm, but numbers are going to contain those values, okay? Each added on to the end of numbers. So if I just have my toString and my print line statement, I'm sorry, I didn't do a good job with this formatting, but I'm using the toString method, so this will get printed off to the console. So far, probably okay. Now let's pass this numbers to my method mystery. Okay. So numbers is my argument. It gets passed to my mystery method, and then list is the parameter that's going to be accepted. Now because you're passing a reference, list is going to be your new reference that points to the same thing that numbers points to. Okay? It is not a copy value like primitives are. It works like an array. So you're passing a reference. Okay? So numbers and lists are going to point to the same location in memory. So when you come down here, okay, what is this doing? Let's try to describe this in English here. So I'm going through list.size. So I'm traversing through the array list. I'm getting the element. I'm checking if it's even. Oops, I didn't mean to cross that off. I'm checking if it's even. Okay. If it's even, I take that element, I multiply by -1, so I make it negative, and then I set I equal to that element. So that says in plain English, go through the list. If the element is even, make the element negative. Okay. And I say plain English because then I don't have to trace through messy code. I can just look at my array list and change it like a human would, right? So where's my even elements? All of those even elements are going to become negative. Okay. That's what that mystery method did. Okay. That's what that mystery, and it did it all on list. Okay. And list is pointing to this location in memory. So then when that method is over and I come back up here, list, that reference list is eliminated. Okay? It's garbage collected, remember. So it doesn't exist anymore. But notice how the changes made to numbers do persist. Okay? And that's because you're passing a reference. So now when you go to print off numbers, that is what your console will print off. Okay. Pass it. So it works just like arrays. Okay. Arrays, we ran into the same thing, exactly like arrays. Okay. Let's talk about returning an array list. So returning array list works very similar to arrays. Okay, identical to arrays, basically. Remember, you're passing references when you're exchanging those variable names. You are not passing values. Okay, passing values is what primitives do. You are actually just exchanging variable names and passing references. So again, an example, we'll trace through the code to determine what is printed at the end here. Okay, so array list, I'm going to have trees, and I add 5 different trees. Woo! 5 different trees. Pine, oak, maple, spruce, coconut. Those were the first 5 trees that came to mind. So then I have a mystery call. Okay, what's going on here? So it says tree mystery trees, right? So that means I'm going to come down here to tree mystery method. 2 things to note about this mystery method. It accepts an array list as a parameter, and it returns an array list. Okay, so this would be the syntax for returning an array list. Okay, so I'm passing it trees, and trees is going to become list, kind of like how it did in the last example here, right? So list is going to point to the same location in memory as trees. And then I'm going to do this. Okay, what does this gibberish code mean? No, it's not gibberish. We know what this means. So it says go through the list, right? That's what this first line of code says. Go through the list. String size variables list.getI.length. Okay, so that's the first time we're seeing kind of code like that. What does that mean? So list.getI says get the string, and then that string.length. Okay, so you're finding out the length of that string at that element, and you're going to store that integer in string size. Okay, so the length of the string is stored in string size, and then inside this it says list.get. So again, get the string, and then look at the substring. Okay, string size -1. Okay, string size -1 means the is the last index. Okay, that's the last string size -1. That's going to be the last index of my string. If that's equal to E, we're going to do something. Okay, so that whole line of code, that chain of methods, says if the last letter of the word is an E in plain language. The last letter of the word is E. What are we going to do? Well, we're going to set that element, we're going to make that tree. Okay. So again, plain English, for every element in the list, get the length of the word. If the last letter is E, change the word to tree. Okay. So which of my trees in my list have an E at the end? Pine, maple, spruce. So all of those get changed to tree. Put that loop into plain English to help you understand what's going on. Okay. And then it says return list. Okay. Now again, when you're just like when you passed it to your method, when you're returning a list, you are also passing a reference. Okay. So this list gets passed back and gets linked to new list. Okay, which basically means it says, okay, you're going to have a new list that is going to point to the same location as list. So list goes away because it was part of this method down here and it got garbage collected. But new list points to the same location as listed. So it's also pointing to trees. So when you print off trees or when you print off new list, you are printing off the exact same thing because they're both pointing to the same location in memory. Okay. Just like erase, or just like erase, kind of weird. Something that sometimes kind of helps when we create an array list, remember we use the new operator with a constructor. That is the only time that we carve out space in memory. Notice how all of these other times, we never use in any of these, we never use the word new. Well, I mean, it's part of the variable name, but we never use the keyword new, and we never call in a constructor. And because of that, that's why we're just passing along references, right? And why everything is actually pointing to the same location in memory, because we never constructed a new space in memory. We just passed references and everything referenced the same space in memory. Okay, so that's a good way to think about this with an array list. And even with an array, when you create a new array, if you're not using that new keyword, you're not constructing space in memory. Okay. All right. I think that brings us to the end. Yes, it does. Okay. So thank you guys so much for following along in this lesson. Hope it was good for you. And I will see you in the next lesson. Thanks for watching.